Okay, this is just a wrap-up of the last part of 3.10, and we'll do a warm-up on this on Thursday. But so the theorem that we hit is that if you have a function and its inverse, that the slope of the function and the slope of its inverse function are actually reciprocals. So if that's true, then the derivatives are also reciprocals because a derivative is a slope. So if you have a point on f that's x0, y0, that's going to map to the point y0, x0 on f inverse. So we can evaluate the derivative without actually finding the formula for the derivative of the inverse function of f of x. So let's try an example. Here's the theorem that we're going to employ. So let's try an example. I'm going to pause here and scroll down. So here's the example we're going to be at. We're asked to find the derivative of the inverse of this function at a point, and the point is 12 comma negative 3, without actually finding the derivative of the inverse. Okay, so we're going to follow this procedure, and we're going to use the theorem that we just reviewed. So the point 12 comma negative 3 is a point on the inverse function of x. Okay, so given that the point negative 3, 12, if we swap the x and the y, that's going to be on f, and that's by definition of inverse functions. Okay, so by definition of an inverse function, you're swapping your x and your y coordinate. So let's find the derivative of x, of f of x. And the derivative of f of x, here's f of x. Right? The derivative of that is just 2x minus 2. Evaluate it. So evaluate the derivative of x at x equals negative 3, right? Because that's the point that's on f, right? This point is on f. So let's evaluate it. And we get f prime of negative 3 is 2 times negative 3, negative 2, and that's equal to negative 8. So having evaluated the derivative at a point, right, on f, by using the theorem, we can get the derivative of the inverse function, and that's just the reciprocal. So at the point 12 comma negative 3, the derivative of the inverse function is negative 1/8, the slope of that tangent line. So we didn't need to find the formula, right? That's the important thing to realize here. You don't need to find f inverse prime of x. You just can use the understanding that inverse functions have reciprocal slopes, therefore the derivatives do, and this is the process that you follow. We'll do a warm-up on Thursday.